Ever wondered what happens when you put a piece of zinc in a copper sulfate solution? You're witnessing a displacement reaction. Now, let's break this down. Displacement reactions are chemical dances where a more reactive element, like our friend zinc here, cuts in and replaces a less reactive element in a compound. In this case, zinc gallantly steps in, displaces copper from the solution, and forms zinc sulfate and copper. So, in essence, a displacement reaction is like a game of musical chairs, where a more reactive element takes the spot of a less reactive one. Now you may ask, how exactly does this happen? Well, it's all about the reactivity series. Let's dive right in, shall we? The reactivity series is a handy list that ranks elements based on their reactivity. Picture this as a leaderboard, with the most reactive elements sitting at the top and the least reactive ones at the bottom. Now, in a displacement reaction, the element that's higher up on this leaderboard, that is more reactive, replaces a less reactive element in a compound. It's kind of like a game of musical chairs, but with chemical elements. Take, for instance, a reaction between zinc and copper sulfate. Zinc, being more reactive than copper, can replace copper in copper sulfate. This results in the formation of zinc sulfate and copper. It's like zinc says, "Hey copper, I'm more reactive than you, so I'm taking your spot in the compound." So remember, the key to understanding displacement reactions is knowing the reactivity series. So let's recap what we've learned about displacement reactions. These reactions are all about a more reactive element stepping in and replacing a less reactive one in a compound. It's like an intense game of musical chairs, where the most eager participant wins. The key to predicting the outcome of these reactions lies in understanding the reactivity series. And that's displacement reactions in a nutshell. Keep exploring and you'll find chemistry is full of exciting reactions like these.